Section 300.3b of the 2002 National Electrical Code addresses the protection of conductors entering or leaving a building. This section states that conductors entering or leaving a building shall be protected to the point of entrance or exit by one of several specified means. One acceptable method, detailed in subsection 1, dictates that service entrance conductors entering underground shall be protected by a raceway from the point of entrance to the service equipment location. In the described scenario, a contractor installed electric service to a new 2-unit condominium. The 2-unit meter center, complete with main overcurrent protection, is located on the outside of the building. The central question revolves around whether it constitutes a code violation to run a feeder through the basement of one owner's condominium unit in order to reach the second unit. The answer is definitively yes, it does constitute a code violation. Section 300.3b of the National Electrical Code directly addresses this situation. The feeder in question is running through the basement of a separate owner's condominium unit. This basement is not considered a service entrance location. Therefore, according to the code, the feeder must be protected by a raceway. Acceptable raceways include, but are not limited to, conduit or cable tray systems. The purpose of this requirement is to ensure electrical safety and prevent potential hazards. By mandating a raceway, the code minimizes the risk of physical damage to the conductors, which could lead to short circuits, ground faults, or even electrical fires. The raceway also provides a degree of protection against environmental factors, such as moisture or corrosive substances, that could degrade the conductor insulation over time. Furthermore, the raceway helps to contain any potential arc flash or arc blast that might occur in the event of a fault, thereby protecting individuals and property in the vicinity. It's important to understand the specific language of Section 300.3b in its entirety to fully grasp the implications of this code requirement. The term conductors, as used in this section, encompasses all electrical conductors, regardless of their size or voltage level. The term entering or leaving a building refers to any conductor that passes through the building's exterior wall, floor, or roof. The term protected to the point of entrance or exit means that the raceway must extend from the point where the conductor enters or exits the building to the service equipment location, which is typically the main electrical panel or meter center. The phrase service entrance conductors entering underground specifically addresses situations where the electrical service enters the building from an underground source. In such cases, the raceway must extend from the point where the conductors emerge from the ground to the service equipment location. The use of a raceway is not merely a suggestion, it is a mandatory requirement of the National Electrical Code. Failure to comply with this requirement can result in code violations, fines, and potential liability in the event of an electrical incident. It is therefore crucial for electrical contractors and installers to be thoroughly familiar with Section 300.3b and all other applicable provisions of the National Electrical Code. In the context of a condominium building, the issue of running feeders through individual units can be particularly problematic. Each condominium unit is considered a separate dwelling, and the electrical system for each unit must be independent of the others. Running a feeder through one unit to serve another unit creates a potential conflict of interest and could violate the privacy and property rights of the unit owner. It is also important to consider the potential for future modifications or alterations to the building's electrical system. If a feeder is run through one unit to serve another unit, it could make it difficult to make changes to the electrical system in either unit without affecting the other. This could lead to disputes between the unit owners and make it more costly and time-consuming to perform electrical work. In order to avoid these problems, it is essential to design the electrical system for a condominium building in such a way that each unit has its own independent electrical service. This means that each unit should have its own meter, electrical panel, and set of feeders that run directly from the meter center to the unit. It also means that the feeders for each unit should not pass through any other unit. If it is necessary to run feeders through common areas of the building, such as hallways or stairwells, they should be installed in a raceway and properly labeled to indicate which unit they serve. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect the latest advances in technology and best practices. It is important for electrical contractors and installers to stay up to date on the latest edition of the National Electrical Code in order to ensure that their work complies with all applicable requirements. In addition to the National Electrical Code, there may be other local codes and regulations that apply to electrical installations in a particular area. It is important to check with the local authorities to determine what codes and regulations are in effect before starting any electrical work. The consequences of violating the National Electrical Code can be significant. In addition to fines and other penalties, a code violation can also create a safety hazard that could lead to serious injury or property damage. It is therefore essential to take the National Electrical Code seriously and to ensure that all electrical work is performed in accordance with its requirements. In summary, running a feeder through the basement of another owner's condominium unit to get to the second unit is a violation of Section 300.3b of the National Electrical Code. This section requires that conductors entering or leaving a building be protected by a raceway, such as conduit or cable tray. Failure to comply with this requirement can result in code violations, fines, and potential liability in the event of an electrical incident. It is therefore crucial for electrical contractors and installers to be thoroughly familiar with the National Electrical Code and to ensure that all electrical work is performed in accordance with its requirements. Always consult the latest edition of the National Electrical Code and any applicable local codes and regulations before starting any electrical work. This scenario specifically highlights the importance of understanding and adhering to the National Electrical Code to ensure electrical safety and prevent potential hazards. Electrical installations must always prioritize safety and compliance with established codes and regulations. When working on electrical systems, it is imperative to verify all components for safety. This can include checking for the presence of a UL listing or other certification to assure that the electrical equipment meets safety standards. It is essential to verify that all electrical equipment is properly grounded to minimize the risk of electrical shock. Ensure that all electrical connections are tight and secure to prevent overheating and potential fires. Use appropriate wire sizes and overcurrent protection devices, such as circuit breakers or fuses, to protect against overloads and short circuits. Always disconnect power before working on any electrical circuit to prevent electrical shock. Use appropriate personal protective equipment, such as safety glasses and gloves, when working on electrical systems. Never work on electrical systems in wet or damp conditions to avoid the risk of electrical shock. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. Do not attempt to perform electrical work if you are not familiar with the National Electrical Code and other applicable codes and regulations. When in doubt, consult with a qualified electrical inspector to ensure that your electrical work is safe and compliant. Regularly inspect your electrical system for any signs of damage or wear and tear. Have your electrical system inspected by a qualified electrician at least every 3 years. By following these safety guidelines, you can help to prevent electrical accidents and ensure the safety of yourself and others. Remember that electricity can be dangerous, so it is important to take it seriously and to always follow safe work practices. Section 300.3b is not the only relevant section in the National Electrical Code. Depending on the specific circumstances, other sections may also apply. For example, Section 310.15 addresses the ampacity of conductors, which is the maximum current that a conductor can carry safely. Section 250.4 addresses the grounding of electrical systems, which is essential for preventing electrical shock. Section 408.36 addresses the overcurrent protection of panel boards, which is designed to protect against overloads and short circuits. It is important to be familiar with all of these sections in order to ensure that your electrical work is safe and compliant. In addition to the National Electrical Code, there may be other industry standards that apply to electrical installations. For example, the National Fire Protection Association publishes a number of standards related to electrical safety, including NFPA 70E, which addresses electrical safety in the workplace. It is important to be familiar with these standards as well in order to ensure that your electrical work is safe and compliant. Electrical safety is a shared responsibility. Everyone who works with electricity, from homeowners to electricians, has a responsibility to ensure that their work is safe. By following the guidelines outlined in the National Electrical Code and other industry standards, we can help to prevent electrical accidents and create a safer environment for everyone. When considering electrical installations in multi-unit dwellings like condominiums, it is essential to carefully plan the distribution of electrical services to ensure that each unit receives its own dedicated supply without compromising the safety or privacy of other units. The use of common electrical rooms or closets may be necessary to house the main service equipment and distribution panels, but the routing of feeders and branch circuits should be carefully planned to avoid running through individual units whenever possible. If it is absolutely necessary to run feeders through one unit to serve another, the feeders should be installed in a raceway and properly labeled to indicate which unit they serve. The raceway should be securely fastened to the building structure and should be installed in a manner that does not interfere with the use of the unit. The unit owner should be notified of the presence of the feeders and should be given a copy of the electrical plans. The unit owner should also be informed of any restrictions on the use of the space around the feeders. Regular inspections of the electrical system should be conducted to ensure that the feeders are in good condition and that there are no signs of damage or wear and tear. Any problems that are identified should be repaired promptly. The electrical system should also be tested periodically to ensure that it is operating safely and efficiently. The National Electrical Code requires that all electrical equipment be maintained in good working order. This includes the feeders, the raceway, and the overcurrent protection devices. Failure to maintain the electrical system can result in code violations, fines, and potential liability in the event of an electrical incident. The electrical system is a critical component of any building. It is essential to ensure that it is properly designed, installed, and maintained in order to protect the safety of the occupants and the integrity of the building. By following the guidelines outlined in the National Electrical Code and other industry standards, we can help to create a safer and more reliable electrical system for everyone. The 2002 National Electrical Code, while superseded by more recent editions, provides a foundational understanding of electrical safety principles. The core tenets of electrical safety remain consistent across different editions of the NEC, although specific requirements and technologies may evolve. Understanding the underlying principles behind the code requirements is essential for making informed decisions about electrical installations and maintenance. These principles include protecting against electrical shock, preventing fires, and ensuring the reliable operation of electrical equipment. Electrical shock can occur when a person comes into contact with a live electrical conductor. The severity of the shock depends on the voltage, current, and duration of the contact. Electrical fires can occur when electrical current flows through an unintended path, such as a short circuit or ground fault. The heat generated by the current can ignite combustible materials, such as wood or paper. Reliable operation of electrical equipment is essential for ensuring that the equipment functions as intended and does not pose a safety hazard. The National Electrical Code provides detailed requirements for the installation and maintenance of electrical equipment to ensure that it operates safely and reliably. The code also addresses the use of overcurrent protection devices such as circuit breakers and fuses to protect against overloads and short circuits. Overcurrent protection devices are designed to interrupt the flow of current when it exceeds a predetermined level, thereby preventing damage to electrical equipment and reducing the risk of electrical fires. The selection of the appropriate overcurrent protection device is critical for ensuring that it will function properly in the event of an overload or short circuit. The National Electrical Code provides guidance on the selection of overcurrent protection devices based on the ampacity of the conductors and the characteristics of the electrical equipment being protected. In addition to overcurrent protection devices, the National Electrical Code also addresses the use of ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect against electrical shock by detecting ground faults and interrupting the flow of current. GFCIs are required in certain locations such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electrical shock. The National Electrical Code also addresses the use of arc fault circuit interrupters, or ASIs. ASIs are designed to protect against electrical fires by detecting arc faults and interrupting the flow of current. Arc faults are caused by damaged or deteriorated wiring and can generate high levels of heat, which can ignite combustible materials. ASIs are required in certain locations, such as bedrooms and living rooms, where there is a higher risk of electrical fires.